Dear colleagues and guests, my name is IT1, Assistant Professor, PhD from Technical University of Varna, Bulgaria, Faculty of Computer Science and Automation. Today, on behalf of our team, I will represent you deployment and analysis of Bluetooth Low Energy Network. According to Ericsson's Mobility Report of June 2020, during this decade 5G will continue to improve, but 4G technology will develop along with it. The improvement of 4G networks and the increasing incursion of 5G provide a communication environment that allows the expansion of Internet of Things technologies. One of these technologies is Bluetooth Low Energy. The aim of this study is to examine the obtained received signal strength indicator values from the end sensor nodes and examining the influence of the distance of the static sensors to the coordinator and the speed of mobile ones on the obtained values for received signal strength indicator. The idea is to build a real Bluetooth Low Energy network and to study the values for received signal strength indicator from the end sensors of the company Texas Instruments. The study of variations in received signal strength indicator values was performed by connecting the end sensor nodes with the master one in the star topology. These slides show the experimental topology with static sensor nodes, where one is the master device and two are the static sensor nodes. The tests were performed for 1, 2, 3, 4, 5, and 6 nodes, which are located at distances from 1 meter to 10 meters from the master device. Similar to the tests with static nodes, tests with mobile ones have been made, where one is the master device and two are the mobile nodes. The tests were performed for 1, 2, 3, 4, 5, and 6 nodes, which move at a speed of 0.5 meters per second and 3 meters per second. The results from experiments with static nodes show that for one node, as the distance of the sensor from the master device increases, the measured received signal strength indicator values deteriorate, but the value at 10 meters is significantly better than the previous ones. The results for two sensor nodes show that the measured received signal strength indicator values for one of the nodes are quite close to the values in the experiments with one device. For the second node, it is seen that the obtained values are significantly lower. As the distance from the master device increases, the received signal strength indicator values deteriorate. From the other experiments, the trend is confirmed that at closer distance to the service device, the obtained received signal strength values are better. As the distance from the master device and the number of end nodes in the network increase, the measured values for received signal strength indicator decrease more and more. This is because the communication medium is loaded and the simulation and the simultaneous transmissions of the end nodes in the common communication environment causes interference and a decrease in the quality and strength of the signal. The results from experiments with mobile nodes show that with one sensor or node, the obtained received signal strength indicator values are better at lower speeds. As the speed increases, a deterioration of the obtained values reported. With two sensor nodes, the results for one of them are close to the values reported for the first node. For the results with one node, for the second node can be seen that the values are significantly lower. From the other experiments, the trend is maintained and the obtained received signal strength indicator values are better when the sensors moving at a lower speed. With the increase in the number of sensors and the load on the communication environment, the experiments show that the reported received signal strength indicator values deteriorate. As the speed of the nodes increases, the received signal strength indicator values deteriorate smoothly. This paper presents the deployment of Bluetooth Low Energy sensor network and the study of variations in the reported received signal strength indicator values for static sensor nodes located at different distances from the master device and for mobile nodes moving at different speeds. Experimental results show that the reported received signal strength indicator values for static sensor nodes deteriorate with increasing distance between the end nodes and the master device, with significant changes in the values. The results for mobile nodes show that as the speed increases, the reported received signal strength indicator values deteriorate, but the change in the results is smoother. The trend of deterioration of received signal strength indicator values with increasing number of end sensor nodes in the network maintained for both static and mobile nodes. The research in this paper have been carried out under Technical University Varna scientific project, research of the possibilities of integrating machine learning and blockchain technologies for the Internet of Things. Thank you for your attention.